Welcome back. This is the second lesson recording for IM1, February 26, 2021. So let's just summarize what our findings from our zombie apocalypse. So please take notes on this. So with each of the scenario, the rule was the same, that each day any zombie that exists will infect 2 humans. But when we started with 1 zombie on day 0, we came up with the rule that y is equal to 3 to the power of x, where y represents the number of total zombies and x represents the day. And when we started with 2 zombies on day 0, the rule for this situation was y is equal to 2 times 3 to the power of x. X represents the number of days and y represents the number of zombies. And when we started with 5 zombies on day 0, y is equal to 5 times 3 to the power of x. Okay, so from this, what can we conclude? What can we add for day 1 zombie? When we started with 1 zombie, we can add 1 there. Okay, so because we started with 1 there and then 2 there and then 5 there. Do you see the pattern? Again, it is y is equal to a times b to the power of x. The generalized form of exponential function is always going to be y is equal to a times b to the power of x. The variable x is going to be an exponent. And that's what makes an exponential function. And y is our output variable and x is our input variable. A, as you can see, is the initial value when x is equal to 0. Or in the sequences, remember that was the day 1 value, but actually that does not translate very well. So forget that. So it's actually the day 0 value. So it will be the initial value, and b is what we call growth or sometimes decay, depending on whether that number that we're multiplying by is greater than 1 or not. So when it's greater than 1, we call that growth. When it's less than 1, we call that decay, but we'll go into that more in details. So that is a number that is a multiplier. So in this case, because each day each zombie infects 2 humans, we are multiplying by 3 each day. So okay, so then let's move on to a slightly different topic, scaling a graph. Okay, so you're going to be dealing with a whole lot of graphs, graphing in math. If you were given this kind of graph, okay, so and these were the values. X extends from -3 all the way to +3, and y extends from very small number, very close to 0, all the way to very big number, 250. Okay, so y is the vertical axis and the x is the horizontal. So in that case, how should we scale it? Obviously, if I scale the y-axis as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I am not going to reach to 250. Okay, so I need to do something differently. I actually have 25 grids vertically. Okay, I have 25 grids. And my highest unit is 250. So what do you think? How many units for each of the grid? So one grid, should I make it 1 grid is equal to 1 unit? That means this will be 0, 1, 2, 3, 4, 5, 6, 7, and I am only going to extend up to 25. So a lot of these values, this value and this value, will be out of range here. So that's no good. What about if it was 1 grid was equal to 5 units? Then 1 grid is equal to 5 units. That means I have 25 multiplied by 5 is going to be 125. So if I start labeling 5, 10, 15, 20, 21, 5, 30, and so on, I'm going to go extended all the way to 125. That's still not big enough. What if I did 10 units? That would be 10, 20, 30, 40, 50, 60, 70, 80. Okay, that will give me all the way to 250 right there. What if I made it 50 units? Then it will be 50, 100, 150, 200, 250, 300. I think that's going to be way too big. So the best one to choose is one grid for 10 units. Okay, so that we can graph this. Okay, so I am going to choose one grid vertically is equal to 10 units. That means this is going to be 10. I'm just going to mark every other 20, 30, 40, 60, 80, whoops, 100, 120, 140, 160, 180, 200, 220, and 240. Okay, and that last one is 250. Now I do need to label that, especially if each of the grid does not represent 1. If it is representing 1, as in the horizontal axis, it is going to be 1, 2, 3, 4, 5, and -1, and so on. You do not have to technically, however, it's always a good idea so that there is very little ambiguity, and it is actually helpful when you're graphing as well. So I am going to mark my horizontal x-axis values as well. Okay, all right, so then let's try to graph them. So when x is equal to -3, it's very, very small number, very close to 0, but it's not quite 0. When x is equal to 2, it's also still very close to 0, but it is getting slightly higher. When x is equal to 2, 0, I mean, the y is 2. Oops, that's too high. Okay, so maybe over here. When x is equal to 1, it is 10. When x is equal to 2, it is 50. When x is equal to 3, it is 250. 250 is way up there. Okay, so I have just plotted them. Now I can connect the points and draw points to extend, draw my exponential function that looks like this. Okay, and I draw arrows in both directions to indicate that this graph, although it only shows up to these grid lines, it actually extends forever. Okay, it extends forever to going this direction as well as going the other direction. At this point, you're going to be working on card 1 and card 2 of Desmos activity on equations, tables, and graph. Okay, here we go. So card 1 says choosing reasonable units for graph. So this time we're trying to graph this exponential function, and the values extend from, the x value extends from +3 to 0 all the way to -4. So the x-axis would work just fine as it is. So it will be 0, 1, 2, 3, and then extend negative direction as well. For the y value, it goes from very, very small number all the way to 135 is the largest number. Let's see how many grid lines we have. 1, 2, 3, 4, 5, 6, 7, 8. I have 8, and I need to cover at least 135. So if that is the case, what would be a reasonable number of units for each of the grid? If I use 1 unit for each of grid, then I am going to go only up to 16. 16 is not enough, 135. So what if I went to 10 units each? If I went to 10 units each and I have 7, 1, 2, 3, 4, 5, 6, 7, 8. 10 units mean I would go all the way to 10, 20, 30, 40, 50, 60, 70, 80. 80. That's not enough. What if it was 20? That would be 20, 40, 60, 80, 100, 120, 140, and 160. that would cover it. What if it was 100, 100, 200, 300? That would be way too big. So my choice will be 20 units for each of the grid. Then from here, you need to graph them. Okay, so I am going to get my pen and I am going to label my grid as being, this is going to be my 1, 2, 3, and -1, -2, -3, and -4. And then for the y-axis, it's going to be 20 units each, so that's going to be 20, so maybe I'll do it on this side, 20, 40, 60, 80, 100, 120, and 140. You do need to label them when they are not at the interval of 1. When it does not represent 1, then you need to label them. Okay, so let's graph it. When x was equal to 0, y was 5. So that's 10 here, and half of 10 is about here. So I am going to get a different color, and I'm going to put my 5 approximately here. When x was 1, it was 15. 15 will be, this will be half, so that will be 10, and 15 will be about here. When x was 2, it was 45, 40, and then 50, and so 45 will be about here. When x was 3, it was 135, 120, 130, 135 will be halfway there. Okay, so that's the right hand side, positive direction. What about the negative direction? -1 is very close to a 0, so it just gets closer and closer and closer. Very small number by the time I get to the -4. Alright, then now that I have drawn my points, I can connect them by drawing a smooth curved line that looks like that. So that's my graph. This time I need to calculate the entry for the exponential function below. I need to calculate the values here and then decide the reasonable number of units for each grid. Then use the table to sketch the graph. Okay, so when x is equal to 0, then y is 4 times 2 to the power of, instead of x, I'm going to put 0 right there. What's 2 to the power of 0? That's 1. 1 times 4 is just going to be 4. So it's going to be 0, 4. What about when x is equal to 1? That's going to be 4 times 2 to the power of 1. 2 to the power of 1 is just 2. 2 times 4 is 8. What about when x is equal to 2? Y is equal to 4 times 2 squared. Remember, exponents are always before multiplication. So 2 times 2 is 4. 2 squared is 4. 4 times 4 is 16. When x is equal to 3, that becomes 4 times 2 to the power of 3. 2 to the power of 3 means 2 times 2 times 2, which is 8. 8 times 4 is 32. Okay, now let's do the negative direction. When x is equal to -1, that's 4 times 2 to the power of -1. What is 2 to the power of -1? That's 4 times 2 to the power of -1 is, remember how I get rid of the negative exponent? I put it as 1 over. And then 2 to the power of 1, so that's 2 to the power of 1 is just 2, so it's really 4 times half, and that is going to be 2. What about when x is equal to -2? And that is going to be 4 times 2 to the -2 is going to be 1 over 2 squared, which is same as a quarter. 2 squared is 4, so 1/4 times 4 is going to be 1. When x is equal to -3, and so on. So here are my y values. So again, the y values are extending from very small number all the way to 32. So I chose to scale the vertical every 5, and that's my graph when I plot it.